Hey, good morning. Thanks for joining me for scenario 2 for the paired t-test. We're going to run both a hypothesis test and confidence interval for this scenario. This should be a shorter video and won't be quite as detailed as the previous one because we've already introduced the material. So if you need to catch some more details, you might want to watch scenario 1's video. So let's get going. So Professor Andy McNeil measured the time in seconds required to catch a falling meter stick for 12 randomly selected students. This tells me we have 12 students being tested, dominant hand and the non-dominant hand. Professor McNeil claims that the reaction time in an individual's dominant hand is less than the reaction time in their non-dominant hand. Now, we will notice that we have 12 students and each student was measured twice. We have 24 readings, we have 12 students, and each one was measured twice. And because they're measured twice, this is going to make this a paired situation. So I'm going to want to enter this data ultimately here in L1 and this data in L2, and we'll look at that in just a moment. A lot of times it's easier to start off with writing our parameter first, so we'll look at that. Let mu d equal the true population mean. Make sure we have the word difference. And reaction time, dominant minus non-dominant. We have to say the order we're subtracting. Now, he said that he believes the non-dominant is less. So let's just say it takes 10 seconds with the dominant hand. We believe it's going to be less than the non-dominant. So non-dominant is going to have to be greater. So we went in this order. Now, obviously, if we'd gone non-dominant minus dominant, we would have had to switch our inequality. This is going to establish my inequality for my alternative. So the null hypothesis is, or the general belief is, there's no difference in reaction time. So no difference means it takes the same. However, McNeil believes that the dominant is faster or takes less time than the non-dominant, okay? So our conditions, they tell us that it was a random sample. That's good. So random sample happens to be given. The next one is the new condition, or the condition, I say it's new for the paired. We didn't have it for the one sample T. And that the differences are independent. And it's reasonable to assume that student one's reaction time differences does not impact students 4, which does not impact student 7. So it's reasonable to assume that one person's reaction time does not impact the other. It's also reasonable to assume that there are more than 120 students. Quite frankly, you could just say that it's reasonable to assume that there's more than 120 people. We do need to create a box plot, and to do that, I'm going to need to input this data into L1. So which means I go to stat edit, and I've input the top row, the dominant into L1 and the non-dominant into L2. Well, what I need are the differences. So technically I need to subtract this from this and this from this, or excuse me, 177 minus 179, because we went dominant minus non-dominant. Well, that's kind of time consuming, but the calculator will do it very rapidly. So I arrow up so that L3 is highlighted, and I press second 1 minus second 2, and then it populates it all the way down. So I've done the subtraction. From that point, I can go check your y equals, make sure there's nothing on in there. Then go to second, stat plot. You really want stat plots 2 and 3 off because that can create other issues. Stat plot you want on, so you press enter, then arrow to the right and press enter, make sure it's on. Now we're going to arrow down and select the box plot that shows outliers, because if they're outliers, we need to know about it because that creates a problem. All right, our dominant was an L1, our non-dominant is an L2, and what we care about are the differences, which are an L3, and you just do second followed by the number 3. And at that point, you can press zoom, followed by the number 9. And there we get our box plot. And this distance is about the same. So about half the data is here, and that's about the same distance along the number line. I don't see any outliers. I don't see any excessive skewness. It's not perfectly symmetric, but no real problem there. So I can get my important values by using the trace feature and get those values that way. Okay, so there's my box plot. I've labeled it reaction time, dominant minus non-dominant. Now I'm ready to run my test. Well, what I have is, for my formula, x bar d minus mu d sd divided by the square root of n. Now, in this case, we know that mu d is our claimed 0. Well, where do I get these values? Well, I can go to stat calc one variable statistics. My list is an L3 that I care about, and I can get it that way. I personally prefer to go ahead and run the test, so I'll go stat test, and I get a t-test. I'm working with data, so data needs to be highlighted. My mean is 0. My list is an L3, so second 3. And we said that our inequality is less than, so I need to make sure I have less than selected. Press enter. Oops. And then I need to calculate. And so there I get a bunch of information. Here's my t-statistic, my p-value, but that's my x-bar that I need. So I have negative 0.0132 minus the 0, which came from the mean. So there's my x-bar. This is my mu d, x-bar d, mu d. There's my standard deviation, 0.0164. And that was my sample size, which is 12. It's not 24. I've put 24 readings. I have 24 readings, but I only sampled 12 people. And that it equals the probability that t is less than negative 2.776 and gives us a p-value of 0.009. So I'm going to real quickly kind of give us a drawing of what's actually going on here. So our claimed mean was that it's going to be 0. Well, we ended up getting so this is our claimed mean, our mu d. We ended up getting an x bar of negative 0.013. Well, negative means it's below, so it's negative 0.013. This is my x bar. So those are my actual values. We said we're shading this way because that was our less than. And then my t-statistic is all t-statistics are centered on 0. And I ended up getting a t-statistic of negative 2.776. And this shaded area is my p-value, which is 0.009. All right, well, 0.009 is less than alpha. So we're going to reject the null. And here's our statement. Our p-value is 0.009. We reject the null. There is sufficient evidence that alpha equals 0.05 to suggest that the true population mean difference in reaction time, always have to say which way we subtracted, is less than 0. And basically, we can say in this case, we know the dominant hand is faster. All right. So in this case, we know the dominant hand is faster. All right, we're going to look at the confidence interval next. And we're going to create a 97% confidence interval. We already have our data in L1 and L2, and we've already defined our parameter, and we've done all of our conditions. We did that in our previous page. So there's no need to do that twice since it's the same material. So my formula, x bar d plus or minus t star sd divided by the square root of n. All right, so once again, how do I get that information? Well, I know we just ran it. We could just rely on that. But remember, you can go to stat calc, one variable statistics. Our list of differences is an L3. And there's x bar d and sd is right there. And there's my sample differences of 12. So all that information is there. And quite frankly, just remember your box plot information as well, if you like it. All right. Next thing, the other way I like to get it is I like to go ahead and just run the test now. So stat test, and we're looking to do a 97% confidence interval. So we're going to drop down to number 8, which is the t interval. We are using data. Our differences are in L3, and we want a confidence level of 0.97. And so I go about calculating it, and this is my lower bound and my upper bound, but there's my x bar again, negative 0.013, and my standard deviation is x of 0.016. So I can plug in this value, and this value from this page. But what I'm missing is t star. So we need to go back and get t star. So second bars, inverse t. And in this case, we had a 97% confidence interval. So 1 minus 0.97, close parenthesis, divided by 2. Degrees of freedom, it's sample size minus 1. Well, in this case, 12 minus 1, because that's how many pairs we had. We had 12 pairs. Ann is thinking, and we end up getting 2.49. Once again, I'm a positive person, so I want to write this down as positive. Actually, I just think it's easier to work with. When we ran the test just a moment ago, we ended up getting our t interval, and we ended up getting a lower bound of negative 0.025 and an upper bound of negative 0.0014. So what that really means is we have a confidence interval of 0.97. It's centered on our x bar. Our x bar happens to be negative 0.0132. We end up with a lower bound of negative 0.025 and an upper bound of negative 0.0014. Now, what that means is any value in here, any value within here is a plausible value. All right, any value located inside this is plausible, the lower bound and upper bound. Any value located in here is plausible. Anything outside of it is not plausible. But what are we? Well, we're 97% confident because that's what we ran. But the true population mean difference and reaction time, what order did we go? Dominant minus non-dominant lies within this interval. Now, I should notice something here, that both are negative, and that's going to be interesting in just a moment. We also know that the true in repeated sampling, our method is really good, so we expect that it'll capture the true population mean difference 97% of the time. Okay? All right. One thing we should note is 0 doesn't lie within the interval. So 0 is not a plausible value, and 0 is the probability that there was no difference. So the fact that 0 doesn't lie within the interval means there is a difference. Now, in this case, both are negative, which means a non-dominant had greater, took longer time. So non-dominant took longer than dominant is what this shows. All right. So basically, we kind of can confirm Professor McNeil's that the dominant was faster and the non-dominant did take longer. All right. Thank you for watching this video. The next scenario will be an actual AP question. So I encourage you to watch it too. See you in the next video.